SpaceX's reusable rockets are possibly the biggest breakthrough in rocket technology for the last couple of decades. But why did Elon Musk's SpaceX decide to put so much time and effort into creating these reusable rockets? And how do they actually work? If you were to explore specific areas of the ocean floor, you'd be met by a spent rocket booster graveyard. There are thousands of them that have served their purpose in getting a satellite or shuttle up to space and can never be used again. So up until now, rockets have generally been good for only one use. As you'd expect, this has made space travel insanely expensive. Take the Saturn V rocket as an example. None of that rocket could be reused. When it was used by NASA in the 60s and the 70s, it cost them $185 million per launch. In 2020 money, that's $1.2 billion, and $110 million of that cost went on the vehicle alone. To reiterate, none of this could be reused. NASA's Space Shuttle program had a similar problem. The shuttle itself was reusable, but the rocket stages were not. A single shuttle launch could cost NASA between $576 million and $1.64 billion, and much of this cost was essentially dumped into the sea with the spent rocket stages. Because of this insane cost, as well as two huge incidents involving shuttles, NASA ended the shuttle program completely, and all spacefaring travel was made using the Russian Soyuz system. This is where SpaceX came in. They saw opportunity in NASA's issue. In 2011, they started work on their reusable rocket, and in 2015 it became a reality. But how does this incredible bit of technology work? So, first of all, the rocket is called Falcon 9. The first stage has, you guessed it, 9 engines. Those 9 engines take care of the rocket's liftoff and carry the rocket to about 100 kilometers, which is right on the edge of space. At this point, the second stage separates and fires its own single engine which takes the payload to orbit. While this is happening, the first stage returns to Earth. This is where the really impressive stuff starts. For the rocket to land properly, it has to be the right way up. There are small thrusters near the nose of the rocket which vent nitrogen gas. After the first stage separates from the second, a powerful controlled blast flips the rocket to prepare it for landing. In the past, rocket stages have almost always used every single last drop of fuel on board to boost their payload into orbit. But for SpaceX to be able to land and reuse their rockets, the first stage needs to carry extra. After it's flipped, 3 of its engines reignite, and they use to slow Falcon 9's re-entry speed. When it lands, either on land or on a platform in the sea, Falcon 9's speed has dropped from 4,700 km an hour to just 20. For the kind of precision that's needed to land a rocket safely, SpaceX needed to arrange the rockets on the Falcon 9 perfectly. They're arranged in a pattern which SpaceX calls octaweb for maximum stability. There's one central engine which is surrounded by 8 more, and together they produce the 600 tons of thrust needed for takeoff. Each engine can also alter its angle of thrust, which controls pitch, yaw and roll during its ascent and descent. The grid fins are large, tennis racket looking fins which make minute movements to steer the rocket back towards the landing pad. The movements they make are very small but can alter the rocket's course significantly, just like how skydivers can change their course using very small hand movements. While ideally the entire process would be planned and programmed before the rocket's launch, unpredictable environmental changes, like air pressure, mean the rocket's exact trajectory can't be worked out before launch. This is where the Falcon 9's onboard computer comes in. It has to work out exactly how to get the rocket back down to ground safely in just a few seconds without running out of fuel. It's controlled by a computer rather than a human because the landing happens so fast a human couldn't react quickly enough to guide it down to the ground safely. All of this would be pointless if the landing legs weren't completely up to the job, and luckily they are. There are 4 of them, and they're made from ultra strong, ultra lightweight carbon fibre. They each have a shock absorbing system, and for heavy landings, a core of material crushes on impact to take force out of the landing, doing effectively the same job as crumple zones on road cars. Rockets are almost always launched from very close to the sea. Because of this, when Falcon 9 separates in mid-air, it does so above the ocean. Theoretically, the first stage could fly all the way back to the launch pad where it lifted off from, but this would be very expensive and use a lot of fuel. So instead, SpaceX land the rocket on a platform out at sea called a drone barge. Each drone barge is about the size of a football field. They're fitted with loads of sensors which are in constant communication with the rocket to make sure they align properly when the time comes. SpaceX haven't ever said exactly how much money they save by refurbishing and reusing their rockets, but they have said it's substantially less than half the cost of building a new one. That's not to say that they never need to build a new one though. For them to never have to build a new one, that would mean the system would have to never go wrong, and unfortunately that's not the case. As with any new technology or idea, there are always hurdles that need to be jumped over. From sensor failures to structure failures, with a bit of technology as complicated and precise as a rocket, even the tiniest failure can cause the whole thing to go wrong. In August 2014, a simple engine sensor failure caused this huge explosion. In total, as of August 2018, 14 boosters have been reused, but not every part of the Falcon 9 is reusable. The first stage, fairings, and Dragon capsule can and have all been reused. The second stage, which carries the payload into orbit, isn't. SpaceX found that the cost of heat shielding landing engines and altering the mass for re-entry made it unfeasible for the second stage to be reused. This is where the upcoming SpaceX Starship comes in. It's a rocket that's built from the ground up to be entirely reusable. It's the ship that will take humans to Mars, as well as take a small group of artists and musicians on a once-in-a-lifetime trip around the moon as part of the Dear Moon project. Starship will be a 2-stage rocket. The first stage being the super heavy launch stage used to get Starship out of Earth's gravity with the main payload, and the second stage holds the engines which will be used to travel across space to Mars or the moon. It's been in development since 2012, and we will hopefully see it launch sometime later this year.